Today I'm going to explain the linear regression code. First, we import some of the libraries we're going to use, like NumPy for the equations, Panda for the reading of the other document, and import matplotlib for the plotting. First, we use PD to read the datos casas CSV, that is a document with the data we're going to use and analyze. Then we extract the features from this document. Then we normalize the x value using the mean and the standard deviation for the standardization of this particular value. Then we compute the cost using the training, no, the training examples, and we make our function for the gradient descent, where we utilize these two parameter values, theta 0 and theta 1, and we make our return for our values. Then we initialize our parameters being theta 1, theta 2, and a learning rate and the iteration value. Then we give back our gradient descent function, the values we're going to use, the standardized x value, the y value from the document, and our other initialized values. Then we make a prediction using this function. And when we have the predicted price, we have to assign the value we're going to analyze, or we try to as close as we can. Then we're going to make a plotting to visualize how the gradient descent works, and to see if there's a deviation that may be exaggerated. So if we run this code as is, we can see that the gradient descent is smooth. So we have a result that may be close to real, and we can see that in our terminal, the result that we get for the price is a number, but we can make some adjustments by changing the learning rate and the iterations. First, I'm going to try to run the code changing the learning rate, and we're going to see a drastic change and a little delay by running the program. This is the result. When I change the parameter, the descent is drastically different. The result has changed by a big margin. So I'm going to try to give more iterations and analyze the same value. And we're going to see that the cost function is even more exaggerated, and the price of a house has been increased by a little, but is in theory closer. We can assume that if we increase the learning rate and we give more iterations, the repetition of the function may go in a long range of non impactful computations. Then one other thing we can try is making a prediction for a price that is not in our database. And if we run this, we can see a prediction for a house of 900 square meters. And this prediction, compared to the other house, is mm, kind of wrong, because if a house, well, first of all, we analyze this value in a drastic gradient descent, and we analyze this one out of the sample with a smooth gradient descent. So I'm going to try to recreate the first one with the original parameters to see the difference in prices. So for the same parameters, we can get a reasonable price increase by the of um, amount of land on the whole house.